Hi everybody. This is notes for weathering and erosion and deposition, but we're going to be just talking about weathering today. So weathering is just the process where rocks are broken into smaller pieces. So we have uh, everything from mountains to little pebbles getting broken down. That is weathering, and we have two different kinds. There's physical weathering and chemical weathering. So both of these processes happen in everyday life. You've seen examples of these. A physical change is different than a chemical change, and physical weathering doesn't alter the the object. It doesn't change whatever the material is. So if you have a rock, you break it into smaller pieces, it's going to be made out of the same stuff. It's just smaller. So you can see that here. We take this, it breaks this up into smaller pieces, and it's still the same rock. This is primarily happening in cold and wet climates because mostly because of water freezing and thawing, and that causes the rocks to break when water gets into little spaces, and it creates more surface area, and we'll do a couple labs with this. But as you can see, the area around the outside is the surface area that increases when we break it open. So we still have all the surfaces that would have been on the outside, but now, once it's broken, we have all these spaces in the center as well that are now exposed. That helps to increase the amount of other kinds of weathering, whether it's a more mechanical or physical weathering, or whether it's more chemical weathering. The types of physical weathering, there's four types that we'll focus on, but this is the biggest one, this frost wedging. And it occurs where we have cold climates where the water will freeze, and it has to get down to the freezing point because once it freezes, if water gets into these little cracks, it will expand and then break those rocks into pieces. And you can see that here. This rock had some cracks in it. Water seeped down in, and it expanded and broke the pieces apart. And now all these surfaces are exposed to weathering as well. We also have something where plants are important to weathering, where roots are growing into the rocks, and as they grow, they force their way into little spaces, and as they get bigger and bigger, as the roots get bigger and bigger, they push the rocks apart. We see this with cracks in the sidewalk. We see this with lots of plants growing underground. Uh, this is another example. You can see a nice picture of these roots growing into these cracks, and when they get bigger, they break it open. Abrasion. This is something that you may have seen in some questions we've had on tests before, or on homeworks before. Abrasion is just sort of like rubbing it off. So it's the bumping and colliding of rocks as they're moving in, either within a great glacier or within water in a stream. The rocks will be tumbling around one another and breaking each other into smaller pieces. They get smoother, rounder, and smaller. And then we have something called exfoliation, and you've probably heard this in common terms in commercials for things that cosmetic things that will exfoliate your skin. It scrapes off the dead skin cells and makes you look younger. So this is a similar process, but here what happens is, as this is being lifted up, the rocks are expanding, and sheets of these rocks peel off, and this unloading uh, is what happens which allows these rocks to rise, and the decreased pressure allows this to go up, and as it does, it expands. So it was once underground, and as it comes up, it has to expand when it spreads out like that, and when it does, it breaks off those rocks as they're going right in here. We can see it. Here's an example of that type of weathering where these sheets of rocks will break off. That's physical weathering. All the rocks have stayed the same. There's no chemical change that's happened there. So it's just a physical breaking up of the rock. The next is chemical weathering, where you're actually changing the composition. It's a chemical process. The elements within the rock are breaking apart and reforming into other compounds. It dominates in warm, humid climates because warm climates you have more chemical reactions. Chemical reactions happen faster when it's warmer. It occurs on the surface of the rocks, which is why that increasing surface area is important for when you have physical weathering breaking the rocks apart. You can get into the center of those rocks, and it allows more of these chemical reactions to take place. There's a few examples. Oxidation, you've seen this, everybody's seen this. Basically, it's rust, rusting. Oxygen reacting with iron compounds produce a chemical change. You cannot take this rust and convert it back into metal. You could take some of those rocks and put them back together, probably smash them back together, and it would still be the same rock. With rust, that rust, if you break the rust off, you can't get the iron or steel back. This happens out in the southwest. This is actually the red part, the darkest part is oxidized, and what native cultures used to do is make these drawings on the rocks, and they would scrape away the iron oxide on the outside, and it would leave this reddish rock underneath. So the reddish rock has iron in it. It oxidizes and turns this dark brownish red, and when they scrape it away, you're seeing the underlying rock that's underneath that. Carbonation, we've talked about carbonates with minerals, and when water moves through the air, it picks up a little bit of carbon dioxide, which creates carbonic acid, which is a very weak acid. When it hits certain minerals, think about the minerals that dissolve with an acid, calcite, dolomite, those rocks or minerals break down with an acid, they change. You're going from the mineral calcite mixes with acid, and it creates carbon dioxide, water, and so it's dissolving those. And you can see this with gravestones. There's gravestones that are made out of marble. Marble is primarily composed of calcite, and when those marble stones, headstones, are weathered over time, it dissolves them, and it makes them hard to read. The other types of gravestones, the ones that are made out of granite or other igneous rocks, don't break down as well. They don't break down like this because they don't have calcite in it. So these older headstones that are made out of marble tend to wear down, break down. And then hydration, this happens with lots of igneous rocks. What ends up happening is the water mixes with the feldspar, that potassium feldspar, and when the water mixes with that and there's a chemical reaction happening, it creates these clay minerals, and it helps to break up those igneous rocks and leaves behind the quartz, which is much harder and less resistant to weathering. So those are the main types of weathering that we're going to talk about. When we look at the composition of rocks, when we look at these layers, each A, B, C, and D represents different kinds of rocks. So A is a different kind of rock from B. And if we look at this, the one that is the most worn away, so if at one time this whole area was the same, was sticking out to the same point, it was weathered, and the one that was least weathered is D. It's not weathered at all. The one that's most weathered is A. It was broken down and eroded or weathered away and picked up and carried away. We call that erosion. So here you can see the layers get broken down differently based on their composition. Weaker, less resistant rocks weather away faster. If you're more resistant, if you resist something, you don't want to do it. So if you're resisting weathering, you're not going to weather. If you're less resistant, it means you will weather. So those terms you have to kind of wrap your head around, because you see them in questions a lot, and it's the most common thing that tricks people with the wording on these Regents questions. And these Regents questions are hard to read as it is, and part of the reason is because they use these terms like less resistant or more resistant. And if you can remember those and get those in your head as to what they mean, from the basis of what you know already. If you resist something, you don't want to do it. So if you're less resistant, you're less willing to do it. So you're going to actually do it. So less resistant means you're not going to be as resistant to breaking down. So this layer up here is the least resistant to weathering. And that's all we're going to do for now. So if you have any questions, let me know, and please go through and answer the questions on the